Perfect. So it's going to be a mix between slide and live demo. I like to do live demo. No risk, no fun. This is what I like to say. So I'm going to quickly present the company for which I'm working for. So this is CloudSigma. CloudSigma is a managed cloud service platform, and we are providing an operating cloud for 15 service provider in country. And meaning in country, we have to keep in mind cloud sovereignty, data sovereignty. My role at CloudSigma is to lead the pre-sales activity. And today I'm going to share some experience with my customer about data sovereignty. Everybody wants to do AI, but when you are working in AI and then you try to build agentic AI workflow, you have to understand what I call the life of a packet. It's like when you are working in network, you have to understand from the source to the destination where your packet goes. And in AI, it's a little bit the same. So if you do a quick chat GPT, which is where my data are stored using ChatGPT, you know the answer, okay? Every data that you are giving to any GenAI application or SaaS platform are stored where the company is located. So OpenAI is based in the US. They have satellite everywhere. Same for Alibaba in China. So the point is, when I put that into my chat prompt, the data goes somewhere. How is it used? Why are they using that? That's the point. And we need to understand the life of a packet. So I'm taking just an example of a basic user who is doing that. Now, if I'm taking another example of someone who is doing software development, for instance, I have here a code which is in Cursor, a very simple Python code, which is not the point of the discussion today. And I just put into the AI chat helper, which is in Cursor. I'm guessing everybody's knowing Cursor. My Cursor is connected to Claude, the Anthropic model. So it means that all the codes that I have here is sent to Claude, and Claude knows about what I'm doing. So it's all about making sure that your IP is your IP and cannot help other companies based on that. So I'm sure that everybody is using his best IDE, and more developers are using connected IDE where they're using AI for software development. So here I'm just taking my Python code and giving it to Claude. So that's the point. Now, the second thing is I have sniffed a little bit the traffic. And when you have a website or whatever, which is exposed to the internet, everybody in terms of big GAFA, let's call that way, do an AI web crawler. So they are fetching all the data they can in order to train their model and provide the services that they want. So the personalized services around what their platform is offering. So as soon as you are providing data to those companies, but also on the internet publicly available, everybody is just fetching your own IP. And the point for for everybody, I guess, is to protect their IP, especially for the EU. So what is the problem statement here? So when you're doing AI and especially AI exploration, it's very difficult to prevent everybody to innovate. And when you do innovation, you have to play, explore all the platform, all the models that today exist. So AI systems needs data mobility and scalability. And I think that everybody is using Gemini or Krog or any systems that is available. So all those providers just manage their own mobility and scalability. However, if we want to keep in mind data sovereignty and all the compliance behind data sovereignty, we have to control a little bit that. And there's 5 pillars to me that needs to be taken into account when you build your data strategy is your data location and jurisdiction. So I'm working not only in the EU, but also for the Asian group of countries, for also the African and the Mercosur. So Latin America, Africa, and Asia Pacs, they all have the same issue regarding data protection. You have global compliance regulation, but also regional and local, and each of these regulations needs to be assessed in order to make sure that what you're doing in terms of data is fine. The second point is everybody's using model for training, some of them. So we heard about the big players who are training the models, but I think that 80% is all about inferencing. And when you do inferencing, you have to know where your model is hosted and how your data are processed. So the point is, can you try to build an inferencing platform on-prem to control your data sovereignty? Trust and control. When you work with a third-party vendor, hardware or software, you have to trust. Some of the vendor provide a all-in-a-box AI system, and you don't really know what's inside. So you have to go through all the OSS license, terms and conditions to understand which type of product they are using, what is the magic glue that they put inside. So it takes you 15 days just to understand what's behind that. So you have to trust and control all of that. The next point is vendor lock-in. Once you start to work with, explore and start to work with some of the nice models that we have, like GPT and Claude, they try to lock you in that platform. So the point is, like in all the domains virtualization, you have to control how you work with your vendor and avoid the vendor lock-in. And the last one is, of course, you have to understand what's behind the compliance and the auditability. And for that, you have to put in place somehow a mechanism to monitor and create all the observability of your platform. So having that said, I just have a look about the regulations that we have in EU. By the way, I'm based in France and I live in Paris. So I was part of the data sovereignty since a bit. So historically, it started more than a decade, but just for the sake of story, every year you have new act or update of the act. Now you have, I'm sure, an organization within your company that works on that compliance regarding the regulation, but it's very difficult to manage both pace. How AI goes into innovation and how compliant we must be in regards to this regulation. By the way, I mean, we have to understand what's behind the Data Act that has been released last year and also the EU Act, AI Act that has been updated this year as well. Let's go a little bit about the live demo now to see, and it's more about a return of experience of what I've been facing with my customer. When my customer wants to build an AI application, 4 things are required. The first one is, of course, an AI platform, which could be no code or low code. There's a long chain, there's DeFi, there's a lot of platform which allows agentic AI workflow to be set up. You need data. And that's the critical point because you need to have the control of your data. You don't want to share your data with the rest of the world. So you need to control how your data is stored and how they are used within your workflow. Of course, you use model, and to use those models, you need GPU to process them. I'm doing some research and benchmark about running the GPU on not RISC, unfortunately, but on ARM, which is RISC-based, as you know, in order to avoid vendor locking with NVIDIA, just to let you know. So there's a very good die company that I'm working with, and the result for inferencing are quite good. So there's a good market behind inferencing in terms of processing of those models. So I go straight to the demo. It's going to be in 6 steps. The first is any company has today corporate data, which are structured or unstructured. In my case, what I do have here in my drive, let me go to download. So I have created 2 fake PDF, which are just payslip, but you get the point here. You have unstructured data. It could be images, PDF, video, audio, whatever that you don't want to share. So this one is a payslip from Jane Doe. Everybody knows Jane Doe. And I have another one, which is probably her husband, John Doe, with a payslip from, I don't know which month. And I'm going to use an object storage in the cloud platform to store all of that. So very basically, everybody is just putting all of those data into an object storage platform, an S3 compliant bucket. So this is where I've put as an HR responsible my PDF payslip. And this will act as a source to process all of that data. So the first thing is to convert those PDF files into data which are structured. So in my demo, what I will do is to connect to what we call, it's a product which is called GenAI Workspace. And in this GenAI Workspace, I have a bunch of connectors which allow to fetch data from different and various sources. So S3 bucket, an HDFS backend, a database which is the matrix one, and a knowledge base which is D5, which I'm going to use. In my case, I have created a data set, which is this one, S3, and it's connected to this bucket. So now I'm going to create a data task, which says, let's use this data set. I can see that those two PDF are here in the bucket, and I want to load them into something which is a volume. So I'm going to use this demo volume here, and I say, okay, put that demo here, put that document here, and just process all the file that you will find in this bucket. So I just put all the file types. I just click on that, and the process is very simple in that case. There's no magic. It's just going to fetch this data and put that into a database which are used as an underlying database below the data pipeline. The second step, so first of all, let's go a little bit on the data. So here, what I can see is those data has been uploaded. Okay, so now we can manipulate them. Nothing has been created yet. It's just the PDF file. The second step is to create awareness based on this data. And by awareness, I'm talking about creating chunk out of this data. If you look a little bit at this document, so there's text, there's a table, and there's signature. So you can think about what type of model we are going to use to process this document and create chunk out of that. So in order to do that, it's very simple. We go to a workflow. We create a workflow and say, okay, demo one, because I think I have already one. I'm going to take my source file, which is the document that I just uploaded, the PDF file in that case. And for the target location, the demo out. Okay, let me create another one. This one, I'm going to use the same. I'm going to use all the documents available. And here I have my canvas where I can play with the workflow. So I have some type of nodes where I can say, okay, use a document parser, use an image parser, use whatever you want in terms of type. And here in this document parser, I will say, use this model for the image model and use this OCR model as well. So here I can play with a bunch of models which are used. And I forgot to mention all the data that I'm processing so that I'm sending to this model, and the data that I have are kept on-prem, meaning in the sovereign cloud. Nothing goes outside of the sovereign cloud, meaning that the data end-to-end resides locally in country. So that's the goal of the demonstration. So based on that, I can create a kind of basic workflow. I will do a split node, which is, you can consider that as a regular, basic, regular expression way to enhance the data. And when you are happy with the flow, you can create, and it will trigger the job of processing those data. So I'm going to show you the chicken which is already cooked. So when I go to this demo out, so this is the data that has been processed in the flow that I've just run before. If I go to the preview, what you will see is the flow that I've just created. Start, document parser, split node, and node. Exactly the same flow that I've created before. On the left, this is the original file that I've shown you, the PDF. In the middle, this is the chunk. This is the first chunk, which is the title. The second chunk is the tables, and the last is the signature. And you can see on the right that it's recognized as a text, as a table, and as an image. So now I have those data which are aware, and I put some metadata creation. So in that model, in that process, I've embedded a little bit that PDF document into chunk with embedded information. So I did the structure awareness and I create some metadata. So just to make it very easy, this is the RAG process, but just a small example of the RAG processes. Then the next step is to convert this data into something that can be consumed by an AI agent. And in order to convert that into something that can be used by an agent, you have to use a vector database. So all of this metadata and chunk has to be converted into floating point. In the bench that I'm doing some bench about the floating point 8, 16, and 32 way to convert that. But that's something I'm doing in the background. But by the way, those data, which are human readable that you can see here, has to be converted into floating point. How we do that? So what I'm going to do here is to create a data export. But before creating a data export, I will use DeFi. If you don't know DeFi, this is a no-code, low-code platform to build agentic AI workflow. I will create what we call a knowledge base, an empty knowledge base. So I will call demo1 create, and I will just set some permissions for everybody to have access to that. And now in my task, I'm going to take the chunk that I've created and give it to DeFi as a knowledge base. And during the process, what I will do is to embed those data with an embedding model and convert them into floating point, which is used for VectorDB. So in that case, I want to convert this data. So this two payslip, I will call it demo1. I will choose a connector, and here demo1, this is the new database. By default, it says you have no embedding model. The embedding model that I have here, you see, I have Silicon Flow as a provider. I have OpenAI as a provider, but those ones, if you choose those ones as an embedding model, you know that your data will be sent to this platform, and they will have access to everything that you are sending to them. In my case, I'm using a no-llamas model provider, and the data that I will send will stay again on-prem. So we start the process. The task has been launched, and what you will see in the background is something that I've already created as well in terms of knowledge base, is this one. So this is a knowledge base that will be the result of my task. And if you look at those documents, you can see the three chunks. So the table, the title, and the signature, which is here. But still, this is human readable. In the background, what happened is we have a database, which is this UI. And in the database, dynamically, there's tables that has been created. And those tables are named VectorDB. So if you look at the schema, there's the VCF64, which is used for the embedding model. And if I look a little bit at the details of that table, you see that I have this document employee signature. You see this one, but on the left, I have the floating point. So the vector database embedding model that has been created. So this is the floating point. And when I will use my AI agent, you know that it's not a perfect match, it's the closest match. So it will use this floating point to find the closest. So having that said, I have a knowledge base, and now what I need to do is to create an AI agent. For that, DeFi is very straightforward and doesn't need any skills. You just have to create an agent. So I create one for you, very basic, with three steps. Starts. The second step is please use this knowledge base as a private source of information, which is this one that I'm using. Then in the retrieval settings, what I'm using on this one, I'm using some kinds of advanced way to retrieve and to select properly the data. Then the second step is to send those data against an LLM. So in my case, I'm using DeepSeek on-prem, but I have other models that I can choose as well. So you see, this is all the model that I have loaded into my own environment. And then provide the answer. So if I go here and I have a quick preview of that, so I have, you remember, in this knowledge base, two PDF. The first is the one for Jane Doe, and the second one is for John Doe. So if I ask to my chatbot, what is the job role of Jane Doe, he will fetch the data from this KB knowledge base, and he will retrieve, and I hope it will provide me the right job for Jane. So as you can see, Jane is an HR director. Fine, so that's good. So far, so good. What is the role of John? Same, he's going to fetch those data that has been processed, and he can tell me that this is a system engineer. Okay, so this is the way to do that. Now, if you have, the latest point now is to provide observability based on what you're doing. And the last point is how to send all of this data that has been processed and make sure that everything is working fine, meaning that in terms of performance, I'm doing the right thing. For instance, if I'm doing that against an Intel AMD x86 CPU or an NVIDIA GPU or RISC-V architecture, what will be the performance in terms of input, output token per second? So I need to monitor that a little bit. So my app here is monitored by a third party, which is called LangFuse. If you don't know that, it's meant to do LLM observability. And this is the LangFuse dashboard. So I've created for you a dashboard already. And if I go to my tracing sessions, I look a little bit on the latest job that I've sent, I can see that my workflow was taken 5.59 seconds just to fetch the data. And my LLM processing was a little bit less than 3 seconds. So here you can understand the number of tokens generated for each of the steps. So you have full access in your flow and how you can enhance the performance of each of the layers. And that ends that live demo. And I will take one last minute to wrap up a little bit on the key takeaway of that. I would say that if you want to do AI, first build your data strategy. You have to understand what type of data you are going to use, how they are going to use, which model you are going to leverage as well. So by model, I mean the LLM. So that's the two main points. Build your data strategy and understand and define your model as a service strategy as well. Vendor locking is complicated today, but we are still working on that. I think there's still people who trust that sovereignty is the future, and I do trust it as well. So how to avoid vendor locking, you have to understand how it works end to end. I'm sure you know that, but of course you have to avoid to fall into the commercial discussion of, look at that, this is the best solutions. But by the way, you're going to be, at the end, you're going to be vendor locked. Something that I've seen as well in each of the company that I've met, there's some kind of unicorn. You see these guys that are learning very fast and they understand very fast, not at the same pace as the others. So those one are what we call unicorn, and they are spreading the information to the rest of the company. And the point is not to control end-to-end that, is just to educate against shadow AI, because it's very easy to use any AI platform today and to get outcome out of that. But if you want to protect your data, you have to educate about how to use the platform. And that's it for me. Thank you.